Welcome back. Let's continue our discussion on factoring quadratic equations. Let's go ahead and solve the first problem. We have 3x squared plus 15x minus 18 equals 0. We can reduce this equation further. So if we take 3 out of the bracket, we'll end up with x squared plus 5x minus 6 equals 0. 3 is no longer irrelevant. So if you just solve what's within the bracket, we can solve the value of x. So we want negative 6x squared and we also want plus 5x. So what if you do plus 6x times negative x? That'll give you negative 6x squared. At the same time, if you subtract x from 6x, you end up with plus 5x. So let's go ahead and substitute 6x minus x in place of 5x, which would give us x squared plus 6x minus x minus 6 equals 0. So if you take x out of the bracket, you get x times x plus 6 minus 1, x plus 6 equals 0. If you combine the terms, then we have x minus 1 times x plus 6 equals 0. Then we have x equals 1, x equals negative 6. And that's it. Isn't that simple? Let's go ahead and solve the second one. It states the expression x squared minus 8x plus 12 equals 0. X equals to, what's the other value of x? So x squared minus 8x plus 12 equals 0. So we want plus 12x squared, and we also want negative x. So how do we go about doing that? Well, we could do negative negative 6x, right, times negative 2x. That'll give you plus 12x squared. We could also do negative 6x minus 2x. That'll give you negative 8x. So if you substitute that in the expression, we know x squared minus 6x minus 2x plus 12 equals 0. So if you take x out of the bracket here, we get x minus 6 minus 2, x minus 6 equals 0. X minus 2 times x minus 6 equals 0. X equals 2 and 6. So the other value of x is 6. Two positive consecutive multiples of 4 have a product of 96. What is the sum of the two numbers? So let's write down all multiples of 4, starting with 4 itself. 4, 8, 12, 16, 20, 24, and so on. You need to multiply two of the consecutive multiples. 4 times 8 is 32. 8 times 12, I believe, is 96. So that is 96. It's correct. So we need to add the two numbers. So 8 plus 12 equals 20. That is it. So let's go ahead and solve the second problem. The fourth problem. You have a rectangle with a perimeter of 50 meters and an area of 150 meters squared. For this problem, you need to first know what are the formulas of the perimeter of a rectangle and area of a rectangle. Area of a rectangle is length times width equals 150 meters squared, right? And perimeter of a rectangle is 2 times L plus W equals 50 meters. For time being, let's not include the units. That will make the problem a little more easier. So length times width equals 150. 2 times length plus width equals 50. We can either solve for L or W. It's totally up to you. I'm just going to solve for L. So that means if you can reduce this further, so L plus W equals 25. L equals 25 minus W. Substitute L equals 25 minus W in this expression here, which would give us, in this expression here. So that means 25 minus W times W equals 150. So that's 25W minus W squared equals 150, can alternatively be written as W squared minus 25W plus 150 equals 0, right? Now we want 150W squared, but we also want negative 25W, right? How can we do that? Well, we can multiply negative 15W times 10W, that'll give you negative 150 squared. Negative 15W minus 10W equals negative 25W. So if you substitute this in this expression, then we end up with W squared minus 15W minus 10W plus 150 equals 0. If you split this in two halves, W minus 15, if you take negative 10 out of the bracket, it'll give you negative W minus 15 as well. The whole thing is equal to 0. If we combine terms, we end up with W minus 10, W minus 15 equals 0, W equals 10, W equals 15. Okay? We know W, if W equals 10, length equals 15, right? Because 25 minus 10 is 15, right? If W equals 15, length equals 10, right? Because 25 minus 15 is 10, right? What's the difference between length and width? Well, irrespective of how you do it, okay, L equals 15, W equals 10, L minus W equals 15 minus 10 equals 5 meters. Okay, or you could do W minus L, which would also be 5 meters. Isn't that clear? All right, let's continue going. All right, this is one of my favorite problems because it's not difficult, but it's definitely going to take some time to solve it. All right, to determine whether whether the solution to the equation is real, rational, or distinct, let's use the simplified version where you take b squared minus 4ac, which will give you the discriminant, okay? And based on the discriminant, we can determine whether the solution is real, rational, or distinct, okay? So 2x squared minus 6x plus 3 equals 0 is the given equation. This is your A term, this is your B term, and this is your C term. So A equals 2, B equals negative 6, and C equals 3. So B squared minus 4AC would be negative 6 squared minus 4 times A is 2 times 3, right? So that will be 36 minus 4 times 2 is 8 times 3 is 24, which is equal to 12. This is called the discriminant, okay? Discriminant, okay? Because this is not a perfect square root, okay? Well, first let's go to the option that's real. Is this real or not? Well, this number is not negative, right? 12 is not negative. So it's not going to give you imaginary square root, right? If you take the square root of, say, 12, it's not going to be imaginary, right? It is going to be real. Since 12 is not negative, it is real, right? Because 12 is not a perfect square root, okay, is not perfect square, right? It cannot be rational. It has to be irrational, right? So rational is incorrect and irrational is correct. Because b squared, the discriminant is not equal to 0. Okay, b squared minus 4ac is not equal to 0. Okay, that means it is distinct. Okay, if b squared minus 4ac is equal to 0, then it is indistinct. okay? So that means this is possible, rational is not possible, and real is possible. That means options 1 and 3 are possible. So that means it's answer A. It's an easy problem, but the trick is you have to know how to do it on a short span of time. And the only way you could do it is using this expression, which will give you the discriminant. Okay, using the discriminant, you can determine all of the following things I've mentioned. Okay, this is again one of my favorite problems because it combines multiple facets. You know, it's not just simply solving for x using the quadratic expression. It's more than that. Okay, so we now have f of x equals x squared minus 4x plus 2. We have g of x equals 6 minus x. What is the sum of the possible values of k such that f of k equals g of k? As I've always said, when you say f of k, that means you're replacing the x term with the k term. So f of k will become k squared minus 4k plus 2. Similarly, g of k will be 6 minus k. If f of k is equal to g of k, that means k squared minus 4k plus 2 is equal to 6 minus k. So we can bring the k to this side, which would make it minus 3k. And we can bring the 6 to this side, which will make it negative 4, right? It's equal to 0. Now let's solve for the quadratic expression. So we want negative 4k squared. We also want negative 3k, right? So if you do negative 4k times plus k, then we get negative 4k squared. At the same time, if we take negative 4k and add a k to it, then we get negative 3k. So substitute this in place of negative 3k, which would give us k squared minus 4k plus k. Minus 4 equals 0. So if you split this equation in 2/2 and take k as a common factor, it's k times k minus 4 plus 1 as a common factor. So that's equal to k minus 4 as well. K plus 1 times k minus 4 equals 0. So k equals negative 1 and 4. So what is the sum of the possible values of k? That means we add negative 1 plus 4 equals plus 3. That's what the final value of k is, adding the two values, which would be plus 3. All right, let's continue. This will be the last problem in this video. And I have, I think, 2 or 3 more videos on this topic. So let's continue. So we have 18x squared minus 39x minus 84 equals 0. Can we reduce this even further? I believe you can. So if you take 84 and divide by 3, yes, you do get. So if you take 3 as a common factor, then you get 6x squared minus 13x minus 28, okay, equals 0. Okay, 3 is irrelevant. We'll just focus on this. So 28 minus 6 is 168, okay? We want negative 168x squared. At the same time, we also want negative 13x. So how could we get 168 and also get 13? So what factors you can use is, well, 21 times 8 is 168, right? Well, if you don't believe me, do it. So we want negative 21x times plus 8x will give you negative 16a squared. At the same time, if you take negative 21x plus 8x, then you get 21 minus 8 is 13, negative 13x. So that means we substitute this in place of negative 3x. So that means it will be 6x squared minus 21x plus 8x minus 28 equals 0. Here, if we take 3x out of the bracket, we get 2x, 2x minus 7. Here, if we take 4 out of the bracket, or I guess, 4 out of the bracket, we get 2x minus 7 equals 0. So 3x plus 4 and 2x minus 7 equals 0. So x equals negative 4 over 3 or plus 7 over 2. The reason I chose this problem is it looks sort of unconventional, even though it is conventional. Maybe getting the root might take you a little bit because 168 is a large number. You do have to figure out which two numbers I can multiply where I can get 168. The trick I used is the number ends with the 8, so I have to figure out two numbers that can result in a value which contains 8 as the last digit. Okay, that's the trick I used, and I got 21 times 8, which gave me 168. All right, so that's the end of this video. We have more problems on the topic of factoring quadratic equations. So stay tuned, and please don't forget to subscribe to my channel. If you like the content, please share the video with your family and friends, and stay tuned for the next video on this topic.